Hi, I just wanted to add some clarification perhaps to the answers from worksheet one for the momentum unit. And number one asks you about whether or not you'd move backwards if you went through the motion of throwing something but didn't throw something. And the answer to that is no, you would not move. Now, you might move a little bit as your arm is swinging forward, but overall, your momentum would not change. And the reason it wouldn't change is because there'd be no net force acting on your body. And so if there's no net force acting on your body, you see that the product of the net force times time, that is the way that momentum changes. And so since there's no net force acting on your body, then there would be that'd be 0 times time, which would be 0. So there is 0 change in momentum. Number two asks you, what is a greater change in momentum? The clay ball that strikes a wall and comes to rest, or the super ball that strikes the wall but then bounces backwards. Okay, so you use the second part of this equation here, and you realize that it's really mass times change in velocity that can also be used to determine the change in momentum. And the clay ball only goes through a change of velocity of 1 meter per second, whereas the super ball goes through a change of velocity of 1.8 meters per second. Therefore, the super ball has a greater change in momentum. Number three asks you about a collision between a light Beetle and a heavier Hummer. And it asks, first of all, which vehicle experiences the greater force? Well, based on all our discussions in the past about Newton's third law and discussing, for example, you driving down the road and hitting a bug, which exerts a greater force? Well, they would both exert the same force. For every action, there's an equal but opposite reaction. Every force has to come in has to have a pair. And so there'd be the same amount of force acting on either car, no matter the mass. Part B asks you what has a greater change in momentum. Well, if we go back up to our original equation here, and we look to see this part of the equation, F net times delta T, which is the way that momentum has changed, if the amount of force acting on each of the cars is the same, and they collide for the same amount of time, then the product is going to be the same, F net times delta T. Therefore, the change in momentum is the same. Okay, part C asks you which vehicle experiences the greater acceleration. So the answer key goes through Newton's second law here and discusses how if you have a smaller mass, then you will have a greater acceleration. F net's the same, remember. The force acting on both of the vehicles is the same. 4A and B are similar reasoning. So you're basically, for both a padded dashboard and the nylon rope that stretches, you're allowing a force to act over a longer period of time. And so in order to change momentum a certain amount, I'm decreasing the amount of force but increasing the amount of time so that the product ends up being the same, but yet I can sacrifice force for time. And so that's why the padded dashboard is less impactful on human bodies, as well as nylon ropes, because you're not coming to a stop in a short amount of time. And if so, you'd have a high amount of force acting on you. Okay, part C asks you about an interesting phenomenon about trains. And so if you have trains connected together, you have a locomotive and then a bunch of trains behind it. If you have the connection between the train cars being taut, then the locomotive will have to pull the entire mass of all of the train cars. That would be hard to change the momentum of that much mass. So instead, what you can do is you can back up, and that loosens the connection between each of the train cars, so that when the locomotive goes, they're only pulling the first car, the mass of the first train car, until that gets tight, and then the locomotive in the first car will be pulling the mass of the second train car, and so on. So really you're pulling a smaller amount of mass each time you go forward.